Okay, last part of this lecture is I want to give you very briefly a flavor of linear regression and inference in different forms. So you may have seen things like ANCOVA or ANOVA or adjusted, unadjusted analysis, all this other stuff. It's all linear regression. All just different names for the same thing. There's different historical reasons why some people prefer one of these things to the other. And in certain cases, it's maybe like a difference between a small sample approximation that works very well for small samples versus large samples. But at least in moderately sized samples, all these things all these things are basically the same. So the main difference is, are you doing an analysis without additional predictors? So are you just regressing your outcome onto an exposure, basically? In which case, that's more or less ANOVA. ANOVA also covers the case where the exposure has multiple values and not just 1 or 0, but that there's multiple different treatments. But another way of talking about this is it's an unadjusted analysis. You don't have these other possible confounders or predictors in there. And you could basically, in the case where you just have two variables, you can get away with just doing an unpaired t-test or a difference in group means. If you have additional predictors, then this is now called ANCOVA, or adjusted analysis. And again, if you just have an exposure that has 2 values, all of this is just linear regression. So if you see these things, don't be afraid. It's just linear regression. I don't think these terms really should be used anymore. Honestly, I don't think they add any value for the most part. Definitely like not ANCOVA and ANOVA, but these are just things that you should recognize as linear regression. And now, lastly, to kind of close out this section about linear regression inference, there's so much nonsense with linear regression inference, right? By far the most common practice is just to look at a table like this, report a table like this, and then try to say everything you can about every possible research question based on this one table. And that's just not good practice, right? We've seen that depending on the research question you have, whether it's purely descriptive or purely predictive or causal, that there's different ways that you need to interrogate this regression model, and there's different kinds of assumptions that you need to think about. And, for example, in the causal world, you need to think about unobserved confounding. Even just to get the identification, you need to think about model misspecification bias, right? Whereas in the predictive world, everything is really easy. What's the MSE? Compare the MSEs, call it a day, right? So it really depends on what you're doing. But in the predictive world, do you want to be looking at p-values, of coefficients? No, who cares? They don't matter, right? These coefficients are totally irrelevant. They don't exist in the real world anyways. And so that's a really important thing. The coefficients don't exist in the real world. So why are we centering all of our analysis on tables that look like this? What is the F statistic? Oh, and that's even before getting into the fact that all of the numbers that you're getting in general are all dependent on all of these crazy assumptions for the normality and the linearity of the model. So all of this stuff is just not great. And there's some great tweets here. This guy's a pretty famous econometrics professor, and he's excited now that Stata lets you put estimates into a table. Wow! I mean, he's trolling them. I mean, the joke is that Stata's kind of archaic, and it's impressive that they can put things in a table, right? But this is a joke. Now this guy says, they shouldn't put stuff in tables because that they should instead be making it harder to get these tables full of garbage that has no meaningful interpretation that nobody should care about in the first place, rather than giving people a sharper knife to cut themselves with. And this is in line with some of the papers that we read very early in the course, where there's a lot of reasons that statistics out in the real world is done very badly, but one of them is that it's so easy now to get an R package and you just press play and you get some numbers out, but you don't really know what those things mean, right? So the fact that it's way too easy to go get a driver's license and then run somebody over. Basically, we don't have licenses for this, right? It's like our gun laws, right? Like anyone can just go buy a gun, but that doesn't actually make any sense. So I'm not saying that people should have licensing or laws to determine who can run R packages, but at least there should be some self-regulation, and people should be thinking a little more carefully about what they're doing and how they're interpreting their analyses. So that's it for this lecture. I think the next time we'll talk a bit more about model selection, a couple other things, but this is a good place to end it.